Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field to teach you about geological processes. Welcome to the classroom. Today we're going to be learning about cross sections. A cross section is a slice down into the earth to expose what you would see on that surface that you cut. And so today I've got the start of a fold here. All right, we've got a anticline, syncline, anticline, and the limbs here. And I've got some quartz and I've got some pumice there, slightly different colors, and we'll mark out multiple layers and put some sand in between to help us visualize what the cross section will look like. We're going to build up a nice little layer, starting with the quartz. So I've got my layer of quartz on top of the sand, and a little patch here, that's where we'll do the valley. So bring in some more sand, make a new layer. Go with another layer now, it's a pumice layer. So just like in real life, certain layers, they really stand out. They make a real mark of a depositional event. Like the pumice here could be a volcanic event that covered the entire landscape with the pyroclastic flow or the ash. And these layers being very extensive, we can use them from one location. Say this is a big mountain, we can use it from this side to that side to trace out a particular layer from a particular event, and this can help us trace the timeline in this location. If we had a fault here and these two were shifted quite a lot, hundreds of kilometers, but we could pick out the same layer with the same stratigraphy below and above, then we can really use that to help us understand what's happening. So let's try to cover this layer now. So we've got our final deposition, our final mountain building event that's created our anticline, syncline, anticline pair that we have here. And this could be part of a much larger mountainside that is also folded. The folding happens both at the small scale and at the large scale because the pressure is the same that has created those folds. All right, so we've got our anticline, syncline, and first thing that I'm going to do is create a valley here by cutting into our layer. So the layer is right about here. I'm going to create a V-shaped valley. Okay. If we dig down deep enough, we might even expose some of the quartz, but it's pretty far down. So for the purposes of the explanation, we'll keep it like this. So what we see, we know because of our fold, we've got a dipping layer down this way. We can put our right hand on there, the fingers dipping down, dip, and then the strike, we would read it on our compass in this direction pointing behind me here because that's where my thumb is pointing. And so my fingers down dip, my thumb pointing in the strike direction. So we've got a layer, it's dipping also in the downstream direction. The stream, you can imagine the water would flow down this way and you would see the layer now exposed this way, and it actually comes up and it closes across this valley in the down dip direction. And it might be a little bit tricky to see, but in combination with the lecture slides, I hope you can see this layer being exposed on the sides of the valley and then closing. It makes kind of a V pointing down here with this one piece of pumice there. But the idea is that that erosion takes place with time and the stream is eroding, removing the rock and exposing multiple layers as we cut down into it. And if it's dipping in the down dip direction, we actually expose part of it further down the hill, so the V in the valley closes in a down dip downstream direction. All right, so let's cut into our anticline syncline here and see what it looks like in a cross section. So basically, a cross section, we would walk along and get measurements at places where, you know, we've got exposure. Okay, so we'd come along, we've got a point here, a point there, another measurement here, come across here, try to find another measurement to take. We would figure out the orientation. We would see beds dipping this way, beds dipping this way, beds dipping that way, beds dipping that way. And so we have to piece together the information we have. Alternating orientations of bedding dips or foliation dipping means we're dealing with a fold. And so we could think about our fold. We could think about, well, we're in a high area here. What do we expect as we go down over this hill? Do we think the hill is formed as part of that folding event, and the erosion is, you know, focused in the syncline areas because those are naturally valleys? They'll fill up with water and we get erosion along these valleys. We already would have point information across this small mountain, and we would make a model of what we think is underground. All right, we can't do a cross section in reality. We can't slice off the side of the mountain to make sure our layer is where we think it is. We can drill a borehole, you know, and find out, okay, I've got the quartz, it's, you know, 30, 40 meters down, but we can't drill a hole every, you know, few meters to figure that out. So what we need to do is project the knowledge we have at surface and maybe perhaps a few boreholes and develop our cross section. So if we cut in here, basically this is our cross section. Okay, there's our cross section, a slice down into the earth, exposing the rock, and we would have to draw it. We would have to take our measurement from this location and say the beds are dipping down this way, so I'm going to project my beds down this way. We have our borehole that would have drilled down. We see the pumice, sand, quartz, sand again, and we would see that in the borehole, do an oriented core capture, extract that piece, know its orientation in space, and we could see the beds dipping down that way, or the foliation. Come over here, another borehole, see the quartz layer, the pumice at top, and the sand in between, and dipping in the opposite directions. And I hope you can see that we would draw it like that. We would draw on our piece of paper, cut into the earth, measure out the length, take our known observation points and project the information underground that we would see there. So if we had a borehole right here, we would know point information, so we could measure the thickness. All right, we could measure the true thickness, exposing the side of the mountain, and hopefully that'll help you understand what a cross section really is. For the engineering link for this application, if we wanted to create a tunnel through this mountain, it's very key to know what layers you're going to encounter as you go through this mountain, and that will help you cost out the project, know how difficult it's going to be to excavate, what tools you need to use. Quartz is much stronger and harder than the pumice, and so excavating the quartz is going to be a lot more difficult and challenging. We have to use different tools than we would with the pumice, but the pumice is weaker, so we might have more collapse problems. So placing our tunnel in the right layer and knowing where it'll exist underground is very important, and I hope you understand the engineering link and why we would develop these cross sections to visualize what's lying under our feet. That's the engineering link at the end of the day. We need to know what we're building on or building in. Peace out.